Welcome to my channel of maths videos. My name is Karen Daly and I'm a mathematics lecturer at DKIT, a third level college in Ireland. This suite of videos was produced to help students who are beginning their third level career brush up on their basic mathematical skills. This video is on indices or powers. Enjoy! The words index, power and exponent are three words used in mathematics to describe the same thing. What is this? In mathematics, if we write 2 and have a little 4 positioned up here to the top right hand corner of the 2. In English we call this 2 to the power of 4. So I've identified that this number up here, the 4, is what's called a power. And another name for it is index or exponent. This number here is called the base. So what does 2 to the power of 4 mean? Well, in simple terms, it just means 2, the base number, multiplied by itself 4 times. So 2 multiplied by 2, multiplied by 2, multiplied by 2. So here's the 4, it's 2 multiplied by itself 4 times. Now you can work out the value of that. 2 multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 2 is 16. So 2 to the power of 4 has the value 16. One thing to note is that the plural of the word index is indices. So we talk about one index or 2 or more indices. Let's look at a few more powers. Let's say we have 3 to the power of 2. Now we have a special way of saying this in mathematics, and we can say this as 3 squared. So 3 to the power of 2 and 3 squared are the same thing. Armed with our knowledge of what that is, it's 3 multiplied by itself twice, so 3 by 3, and this just has the value 9. Let's look at 4 to the power of 3. Well, 4 to the power of 3, again, we can write it and say it in English in a special way. It's 4 cubed. Right? Knowing what that is, it's 4 multiplied by 4 3 times. So 4 multiplied by 4 is 16, by 4 has the value 64. Let's look at a value, let's say 5 to the power of 1. Now normally when we have a power of 1, we don't normally write it down, because 5 to the power of 1 is just the value 5. What if we had, let's say, a number to the power of 0? So let's say we had 6 to the power of 0. How would you work that out, or what value does this have? Well, by definition, any number, doesn't matter which, to the power of 0 has a value 1. So this is a kind of a special case. Any number to the power of 0 is equal to 1. So let me write that down for you. So any number to the power of 0 is equal to 1. We can write this as x to stand for any number to the power of 0 is equal to the value 1. In mathematics, we sometimes use letters instead of writing down the particular number. So if x is a number, then x to the power of 3, or x cubed, is x multiplied by x multiplied by x. Now it's a little bit confusing with these multiplication signs along with the x's. So normally they're not written in, and normally you'll see it just written as x. Sometimes people put in a dot by x, or normally it's just x, 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 and it's understood that the 3x values are multiplied by each other. So in general, we say that x to the power of n is equal to x multiplied by x multiplied by x all the way over multiplied by x, and here this is done n times. Right? So it's multiplied by itself n times. Let me attempt here to clear up a few confusions. Let's say I have a negative 3 and I want to square it or raise it to the power of 2. Now, knowing what I know, that's just minus 3 multiplied by minus 3. Now remember, if I multiply a minus and minus, I get a plus. 3 3s are 9, so it's a positive 9 is the answer. Now, if I was asked to work out minus 3 to the power of 2, note the difference between the two of these. This is just a minus, and the 3 is just the thing that is squared. So it's minus multiplied by 3 multiplied by 3. Right? The 3, this is 3 squared. Okay? 3 3s are 9, so the answer to this is going to be minus 9. In mathematics, if I write down 2x, right? What I mean by that is that 2 is multiplied by the number x. Now I don't know what the value for x is, so I can't do the multiplication, but x is a number, which I don't know, and 2 is multiplied by it. Now, if I was asked to work out 2x to the power of 3, right? So it's 2x all to be cubed. That would be 2x multiplied by 2x multiplied by 2x. Okay? Here I have 3 2's that are multiplied by each other. So 2 by 2 by 2 is the value 8. Right? 2 2's are 4 by 2 are 8. And I have 3 x's multiplied by each other. And in our language, that's x cubed. Now, if I was to look at 2x and the cubed was just here, right? What that means is that 2 is multiplied by x by x by x. Okay? So note the difference between these two things. Now let's look at a negative index, power, or exponent. So let's say I had 2 to the power of and negative 2. Okay? What that is in mathematics is just 1 divided by 2 to the power of the positive 2. Right? Now remember, 2 to the power of 2 is 2 multiplied by itself twice. So it's 2 by 2. So that's equal to 1 over 4. That's as a fraction. And as a decimal, 1 over 4 is 0.25. Let's look at another one. Let's say 10 to the power of minus 1. Well, 10 to the power of minus 1 is just 1 divided by 10 to the power of 1. And 10 to the power of 1 is just 10. And 1 divided by 10 is 0.1. And let's just look at one more. 5 to the power of minus 3. 5 to the power of minus 3 is 1 over 5 to the power of 3. And 5 to the power of 3 is 1 over 5 by 5 by 5. And 1 over 5 5s are 25 by 5 is 125. And that's as a fraction. And as a decimal, and we can work it out in the calculator, 1 divided by 125 is 0.008. Another way of writing 1 divided by 125, you could write it as 1, and you can put a division sign, and then 125. And as I said, the answer is 0.008. Likewise, if x is any particular number which we don't know the value of, x to the power of, let's say, minus 4 can also be written as 1 over x to the power of the positive 4. So, in general, any number x to the power of a negative n value is equal to 1 divided by x to the power of n. Let me just put a box around that to highlight that x to the power of minus n is equal to 1 divided by x to the power of n. If you've been understanding what I have been doing up to now, the laws of indices will follow very easily. The first law I'm going to look at is x to the power of a multiplied by x to the power of b is actually equal to x to the power of a plus b. Now, x is just a number, a is a number, and b is a number, right? So the simplest way to see this law in action is, let's take two simple values for a. Let's take a as being 3, and let's take b as being 2, okay? Now, if you have x to the power of 3, and you multiply it by x to the power of 2, knowing what I know about my powers, x to the power of 3 is x by x by x. X to the power of 2 is x by x. And if I was to count them, I end up with 1, 2, 3, 4, 5. So I end up having x to the power of 5. And as you can see, 5 is equal to 3 plus the 2 value. Note that to apply the law, the base values here and here have to be the same. So let's do a few examples. The question says, simplify using the laws of indices. Now we only have the one law at this stage, but let's do one. So the first one is, let's say 2 to the power of 4 multiplied by 2 to the power of 7. Okay. Now using the law above here, it says that x to the power of a, my x value is 2, a is 4, and my x value here is 2, and my b value is 7. That's simplified. I just add the two powers. So the two values I'm going to add are 4 and 7. So what I get is that it's equal to 2 to the power of 4 plus 7. And 4 plus 7 is 2 to the power of 11. Okay, let's try another one. 2. Now I can have more than one value here. Here I only had one value, the 2 as a base value. But let's say I had 2x to the power of 3, and I had it multiplied by 2x to the power of 4. Okay. Now, I can only use the law up here if the base value is the same, right? So I have a base value here of 2, and I have a base value here of 2. And the power on the 2 here is not written down, but it's understood to be a 1. And the power on the 2 here is not written down, but it's understood to be a 1 also. So if I simplify the powers of 2 first, using the law of indices, it's 2 to the power of 1 plus 1. Then if I go ahead and simplify the powers of x, here I have x to the power of 3, here I have x to the power of 4, so I just add the powers. So I'm going to get 3 plus 4. So doing that, 1 and 1 is 2, so it's 2 squared, and x to the power of 3 plus 4 is x to the power of 7. Now I can work that out if I want to, and just write it down as 4x to the power of 7. Now let's do just one more. So let's say I had 3 squared by x to the power of 4 by y to the power of 5 multiplied by 3 to the 3xy. Okay. Now again, remember that you can only simplify those that have the same base using this law. So I've got a 3 squared here, and I've got a 3 to the power of 1 here. So if I simplify that first, I'll get that it's 3 to the power of 2 plus 1. Okay. Then if I continue on and look at the x's, x is to the power of 4, and this x here is to the power of 1 again. So here I've got x is to the power of 4 plus 1. And likewise with the y's, this y here is to the power of 5, this y here is to the power of 1. So if I was to simplify that, it's going to be y to the power of 5 plus 1. Now I can do no more. I can add, obviously, my values together and write down the answer. And the answer is going to be 3 to the power of 3 multiplied by x to the power of 5 multiplied by y to the power of 6. Right? I can't bring any of these values together because I don't know the value for x, I don't know the value for y. I could work out 3 to the power of 3, 3 3s are 9, by 3 is 27 if I wanted to, but that's as far as I could go. So it's 27, x to the power of 5, y to the power of 6. Because the powers here are all whole numbers, you could just bypass the law of indices and write the whole thing out as individual powers. What I mean is this. You could redo this question, okay, in this way, and just rewrite it. 3 squared is 3 by 3. X to the power 4 is x by x by x by x, 4 x's. Y to the power 5 is y multiplied by y 5 times. There's 5 of them. Then you've got 3x and y. So if you count all the 3's, you've got 1, 2, 3 3's. So it's just 3 to the power of 3. If you count all the x's, 1, 2, 3, 4, 5. So it's just x to the power of 5. Right? And if you count all the y's, 1, 2, 3, 4, 5, and this one here is 6, you just end up with y to the power of 6. So again, you get exactly the same answer. 27 x to the power of 5, y to the power of 6. Obviously, if these numbers were only fractional were only decimals or fractions, you wouldn't be able to do it like this. Let's look at the next law I'm going to write down. It's going to be that x to the power of a divided by x to the power of b is equal to x to the power of a minus b. Now again, a and b are just numbers and x is just a number as well, but if you wanted to check out how this works, you could just write it out as, let's say, if x is the power of 3 and you want to divide it by x to the power of 2. If I didn't know the law, all I'd have to do is go x by x by x divided by x by x, and there's an x above and below the line, and if something is above and below the line, they just cancel each other out. So these two cancel each other out, and you're just left with x, or what's understood is x to the power of 1, right? So this 1 here was gotten by taking 3, right, and subtracting 2 from it, okay? So let's try a few examples using this law. Okay, here it says, simplify using the laws of indices. So let's look at the first one. So let's do the first one. So let's say you had 2 to the power of 9 divided by 2 to the power of 6. Okay, so the law just says that that's equal to 2 to the power of 9 minus 6, and 9 minus 6 is 2 to the power of 3. Okay, the value can be positive or negative. You can have 2 to the power of, let's say, 6 divided by 2 to the power of 9, and that would turn out to be 2 to the power of 6 minus 9, so it would equal 2 to the power of minus 3, or if you wanted to write it as 1 over 2 to the power of 3, they're the same thing. Okay. Likewise, just like before, we can have multiple values. So let me move down a little bit and look at one that has multiple values. So something like if I had 2 to the power of 2 times x cubed y squared divided by 2xy, let's say. Okay. Now again, remember that you can only simplify when the base is the same. Okay, so the base is the same for 3 sets of values in here. So I'm going to have, the answer is going to be, so when I simplify the 2, it's 2 to the power of, remember, 2 minus 1. Remember, it's understood that there's a power of 1 on that 2 there. Okay, then the x value is going to be 3 minus 1 again, and then lastly the y value is 2 minus 1. So if I work them out, 2 minus 1 is 2, x to the power of 2, y to the power of 2 minus 1 is just 1. Okay, so let's look at another law, and this law says that if you have x to the power of a all to the power of b, that's equal to x to the power of a multiplied by b. Okay. Again, you can check this out. If you had a and b are just numbers, if you had 2 to the power of 3 all to the power of 2, right? Remember what you know about powers. It's 2 to the power of 3 multiplied by 2 to the power of 3. That's the squared part, right? And 2 to the power of 3 is 2 by 2 by 2, and it's multiplied by 2 by 2 by 2, right? So if you count all the 3's, you get 1, 2, 3, 4, 5, 6. So you end up with 2 to the power of 6. And this 6 is got by multiplying 3 by 2. So again, just let's try a couple of these. Simplify using laws of indices. Let's try one. And let's say you had x to the power of 3 all to the power of 4, right? Well then that would be x to the power of 3 multiplied by 4. So it would be x to the power of 12. Okay. As I said to you before, the numbers don't have to be whole numbers, and they can be positive or negative as well. So if I had x to the power of, let's say, 5 multiplied by minus 6, and that would be x to the power of 5 multiplied by minus 6, and 5 multiplied by minus 6 is x to the power of minus 30. And remember, x to the power of minus 30 is the same as 1 over x to the power of the positive 30. You do just one more, number 3. They don't have to be whole numbers. If I had 2 to the power of, let's say, 0.2, all to the power of, let's say, 2, that would be 2 to the power of 0.2 multiplied by 2, so it's equal to 2 to the power of 0.4. Okay, let's look at another law of indices. It says that if you have x, y, or any number of variables, it can be more than 2, and you have it all to the power of a, that's equal to x to the power of a, y to the power of a. Now we looked at that earlier on in a simple example. If you had, let's say, 2x, right? X is 2, y is the x value, and you had it to the power of 2. Remember, we saw that was 2x by 2x, so it turned out to be 2 to the power of 2 and x to the power of 2. So the power of 2 is on both the 2 and the x. Okay. So let's try a few examples with this law. Simplify using laws of indices. Let's try the first one. So let's say I had 4 times y all to the power of 5. So all it says is you put the power of 5 on everything inside the bracket. So it's 4 to the power of 5, y to the power of 5. Right. Let's try another one. If I had, you can have as many values in here as you like, 2xy all to the power of 2. Well, the power goes on everything in there. So it's 2 to the power of 2, x to the power of 2, and y to the power of 2. Okay, and the last law that I want to draw your attention to is this. If you have the nth root, right, now this may be a bit more technical, the nth root of x, right, that as a power is written as 1 to the power of 1 divided by n. I'm going to go to something that hopefully you have seen before. It's called a square root, right? A square root is just written like this, right? But it's understood is that there is actually a little 2 in here, but it's not written down. Now, what is a square root? Let's have a look where that comes from. If you have x squared, right, some number when squared, and you're told that that is equal to 4, you could hopefully solve that in your head. Remember, 2 squared, if you square 2, you get 4. Also, don't forget that if you square minus 2, you get 4 also. But what we write as an answer is that x is equal to, well, it can be plus or minus the 2 value, right? So if you square positive 2, you get 4. If you square negative 2, you get 4. Also what we write down is, sometimes you've seen, it's equal to positive or negative times the square root of 4. And the square root of 4, if you do it on your calculator, is positive or negative times the value 2. So square root reverses the square function, right? If I go back to that equation again, x squared is equal to 4, right? To get rid of that squared and just be left with a power of 1, as I need here on this answer, right? What I could do is I could raise both sides of this equation to the power of a half, right? So here it'll be 4 to the power of a half. If I do it to one side, I have to do it to the other. Because knowing your last law, a number to a power multiplied all to a power, you multiply these two powers. So x to the power of 1 is equal to the positive or negative 4 to the power of a half, right? So here, 4 to the power of a half and square root of 4 are the same thing. Same thing. Okay, so there's where my law comes from. Hopefully that's not too complicated. So again, if I just try a few questions with this law, simplify using laws of indices. So let's say the square root of x. Now remember I said to you, the square root of x, it's understood that there's a little 2 in that. The square stands for 2 of x. So if I simplify it using my laws of indices, it's x to the power of 1 over 2. Okay. If I go ahead and look at, let's say, the fourth root of 2, right, that would be 2 to the power of 1 over 4. Okay, let me finish off by just going through all the rules again and trying this question. The question says, find the value of p in the following. Right. If we look at the first one, it's 3 to the power of 2 multiplied by 3 to the power of 5, and you want the p-value. Well, the law says a number to a power multiplied by a number to a power. What you do is you add the powers. So p is going to be 2 plus 5, so it's equal to 7. For the next one, it's a number to a power all to a power, right? And when you have that, the p-value is going to turn out to be 7 multiplied by 4, so this value is going to be equal to 28. For the next one, it's 5 to a power divided by 5 to a power, and the law says that you take the top value and you subtract the bottom value. And if you subtract the bottom value, you get a minus 2. For the next one, this is a square root. It's understood but not written that there's a little 2 in here. So the power on the p here is that p is equal to 1 divided by 2, or a half, or 0.5. This is a 6 here, and it's the sixth root of 2, so p is equal to 1 divided by 6. And then the last one is 1 over 10 to the power minus 5. Again, if you bring it above the line of division, you change the sign on the power, so the p-value is going to be a positive 5. So let me finish by doing these last three questions. It says simplify using laws of indices, these three expressions. Okay, so let's try the first one. So the first one is all to the power of 2 to begin with. So remember, the power of 2 goes on everything inside the bracket. So it's 2 to the power of 2, it's x squared to the power of 2, and it's y to the power of 2. A number to a power, you multiply the powers. So the end answer, well, you can work out 2 squared if you want. 2 squared is just 4. And then it's x to the power of 4 and y to the power of 2. So that would be the simplified version of this expression here. If I move on to the next one, right, and there's a 3 above the line and a 3 below the line. I could go, using my laws of indices, it's 3 to the power of 1 minus 1, or you could just say, well, that cancels with that because the 1 is above the line. It's a division. 3 divided by 3 goes into 3. 3 divides by 3 equals 1. For the x's, it's x to the power of 3 subtract 2. And for the y's, it's y to the power of 2. There's no y below the line. So 3 minus 2 is 1. 1 minus 1, this is a 0, and any number to the power of 0 is equal to 1. So this whole thing just reads as x to the power of, so that this is just multiplication by 1 will have no effect on the thing, so you don't write it down. So x to the power of 3 minus 2 is 1, and y to the power of 2. You don't normally write that, so you would write it as xy squared. So again, this is a simplified version of this here. Just doing the last one, again, 4 divides into 8. You can just do that as simple arithmetic. 4 divides into 8 twice, okay? So you can just write that down as a 2. And if you want to, this is here, f to the power of 2 subtract 1. So it's going to be 2 times f, and 2 minus 1 is 1. You normally don't write the 1, it's understood, so you just write it as 2f. So that's the simplified version of, that one up here. Okay.